Today we're going to talk about Mars again. But not in the way we usually do it. Because over the past few months, a bunch of discoveries have piled up that, together, change quite a bit of what we thought we knew about the red planet. Rocks with impossible shapes. A stain that's been growing for 50 years without anyone really knowing why. Molecules that are literally the building blocks of life. And even time itself running differently up there. Let's go through all of it. Starting with the strangest thing recently spotted on the surface. Let's start with something that sounds like it's straight out of a conspiracy theory, but actually has a much more down-to-earth explanation. It's a triangular, almost perfect rock formation known as the Kanda tetrahedron. It was first identified more than 20 years ago, but recently went viral again because, of course, it started circulating on social media as proof of artificial structures on Mars. The reality, according to geologists who've analyzed it with high-resolution imagery, is a lot less exciting but just as interesting. It's an inverted relief. Basically, a rock harder than the terrain around it. Left exposed after Martian wind eroded everything else away over billions of years. And if you zoom out from that pyramid and look at the surrounding terrain, you'll find dozens of similar geometric shapes. Wedges. Blocks. Almost perfect angles. It's not a construction, it's the result of extremely even erosion acting on layers of rock with different hardness. But that's not the only strange formation captured recently. The Curiosity rover recently captured something that looks like a honeycomb carved into stone. Or if you prefer a more dramatic image, something like fossilized dragon scales. And no, it's not some alien fossil. On Earth we have practically identical formations. And we know exactly how they form. They're the result of repeated wet-dry cycles. The ground gets wet, contracts as it dries, cracks into that polygonal pattern, and the cycle repeats over and over for years. Seeing this same pattern on Mars is actually one of the strongest pieces of evidence that the planet wasn't simply wet all the time in its past. It had cycles. Periods of water and dry periods. Alternating. What's still not clear is the exact rhythm of those cycles or how long they lasted. And speaking of mysteries that still haven't been fully solved, there's one that's been puzzling scientists for half a century. This one, to me, is the most unsettling of all. It's known as the Utopia Planitia shadow. A dark area inside a massive crater that was first spotted in 1976. With the early Viking probes. Since then, that stain has expanded to cover about 300 kilometers, growing at a rate of roughly 6 kilometers per year. And no one has a definitive answer for why it's happening exactly there, and nowhere else on the planet. By comparing images from ESA's Mars Express probe with old photos from NASA's Viking orbiters, scientists believe it's not a shadow in the literal sense, but rather a layer of dark volcanic material, rich in minerals like olivine and pyroxene, slowly shifting across the surface in the direction of the wind. There are two main theories. The first, Martian wind, which can be surprisingly powerful, is redistributing the dark material little by little, especially during major dust storms. The second, that dark material was always there, but covered by a lighter layer of ice or fine dust. And what we're seeing now is simply the wind cleaning off the surface and exposing what was hiding underneath. Neither one is fully confirmed. What we do know is that whatever it is, It's been active for half a century and it's still spreading. Let me know in the comments which of the two theories convinces you more. Now let's get to what's probably the most important part of this whole video. What the Curiosity and Perseverance rovers are finding in terms of organic chemistry. In Gale Crater, Curiosity used a chemical process to break down collected rock samples and managed to identify more than 20 distinct organic molecules, including compounds called nitrogen heterocycles, which on Earth are considered precursors to DNA and RNA. Now, this isn't proof of life, but it is proof that the basic building blocks needed for life to exist were present on Mars, and have been preserved there for over 3 billion years. Nearly 5,000 kilometers away, the Perseverance rover found something different but just as intriguing. A rock formation named Chayava Falls. Inside it, scientists found small dark spots containing minerals called vivianite and greigite. On Earth, that very specific mineral pattern is almost always associated with microorganisms that get their energy through chemical reactions in wet sediments. On Mars, we don't know what produced it. Several months have passed since the discovery, and there still hasn't been an update confirming or ruling it out. What is true is that, combined with the presence of complex carbon in the same area, it's one of the strongest arguments so far for a possible biosignature. Although, again, there are still no fossils, no definitive proof, and technically all of this could also be explained by purely chemical reactions, with no life involved at all. There's another finding worth mentioning. Scientists found garnet, yes, the semi-precious stone, inside a meteorite we know for certain came from Mars. The problem is that, on Earth, garnet forms under extreme heat and pressure, usually tied to tectonic plate movement. And Mars, as far as we know, doesn't have plate tectonics. So how did it get there? There are two possibilities. Either Mars had some kind of geological activity we don't fully understand yet, similar to Earth's tectonics at some point in its history, or it formed from the impact of a giant meteorite combined with ancient magma flows, locally generating those extreme conditions. Either one opens up a huge question about just how geologically active Mars once was. Let's move to the atmosphere. For years we've asked why Mars has such low atmospheric pressure compared to Earth. And NASA's MAVEN probe, whose entire mission was to investigate exactly this, just gave us a key clue. Scientists recently detected a magnetic twisting effect, which basically involves charged particles from the Sun literally ringing the planet's atmosphere. Kind of like what happens when you wring out a wet towel. We'd already seen this effect in Earth's magnetic field, but this is the first time it's been observed in real time, in depth, inside another planet's atmosphere. And it was only visible thanks to a particularly intense solar storm that amplified the effect enough to detect it. In short, this shows us directly how solar activity wears down the Martian atmosphere over time. And something very similar is probably happening to a lot of exoplanets that don't have a strong magnetic field protecting them. But it's not all bad atmospheric news. There's a much more hopeful finding too. It turns out Mars is capable of generating its own ozone layer, at least in certain areas, specifically inside the North Polar Vortex, where temperatures drop to around -40 degrees, the point at which water vapor starts to freeze. Normally, water vapor destroys ozone. But when that vapor freezes and drops out of the equation, ozone can build up unobstructed during the long Martian winter. What does this mean in practice? That there could be specific areas of the planet partially shielded from radiation by a thin but real ozone layer. Possibly even a permanent one. We still don't know how extensive those zones are. But it's a relevant data point if long-duration human missions are ever on the table. A new study analyzed 2 decades of imagery and catalogued more than 1,000 Martian dust devils, measuring their speed with a precision we didn't have before. The result surprised even the researchers themselves. The fastest dust devils reached speeds of up to 160 km per hour. More than double what had previously been recorded from the surface by landed missions. This not only confirms that Martian winds are considerably more intense than estimated, it also solves a mystery that had gone unexplained for a while. How Martian ice and snow manage to stay suspended in the air for weeks at a time. The answer, according to this study, is simply that the wind is strong enough to keep them up there far longer than we thought. And while these winds aren't strong enough to knock over a human structure, previous missions already ruled that out, they can completely coat solar panels in ice, cutting off an entire mission's power supply. Something well worth keeping in mind for future missions. This is the big underlying question. And ice deposits inside certain craters are starting to function almost like a historical archive of the planet. Those ice layers show that Mars went through repeated cycles of ice accumulation and loss, tied to changes in the tilt of its axis, known as obliquity. Unlike Earth, whose tilt stays stable thanks to the Moon, Mars's tilt can shift far more dramatically, redistributing huge amounts of ice from one region to another. And with each cycle, the total amount of ice seems to have decreased. In other words, Mars has been slowly drying out, progressively, for hundreds of millions of years. Part of that water ended up trapped in minerals beneath the surface, and another part simply escaped into space for good. And to wrap up with something curious, it's now officially confirmed that time on Mars runs a little bit faster than on Earth. Not science fiction, pure general relativity. Since Mars has less mass and a weaker gravitational field, its clocks run about 477 microseconds faster per day. That sounds insignificant on a human scale, but it's absolutely critical for the precision needed by satellite navigation systems and future interplanetary communications. And as an extra fun fact, the Moon also runs at a different pace relative to Earth, but slower than Mars, about 56 microseconds faster than Earth, compared to Mars's 477. Every body in the solar system, literally, runs on its own clock. And with that, we wrap up today's rundown. Rocks that look artificial but aren't. A decades-old stain still without a full explanation. Molecules that could be the first step toward life. And even time running at a different pace on another planet. Mars has stopped being just a curious destination. It's becoming a natural laboratory for understanding how planets evolve and, maybe, for answering the biggest question of all. Are we alone? If you enjoyed this rundown, subscribe to the channel so you don't miss the next ones. And let me know in the comments which fact from today surprised you the most. I'll read all of them, so don't hold back. See you in the next video.